I'm CK. Today we've got a module from Random Source. It's their Serge VCF-Q. So it's a Serge, their interpretation of a Serge filter. And looks pretty good. We'll put it together, see how well it goes together, and then see how it sounds. And I hope you enjoy the video. Let's see what's in the package. We've got three things. We've got PCB and panel, I'm sure, in here. The general parts, and again, got to pick this up from thonk.co.uk. There's a QR code for the build document. And then the VAT chip, the VAT 2180C. So let's crack the bag open of the PCB. Not bag, the non-recyclable bubble wrap. I haven't done anything from Random Source so far, so we'll see. Two PCBs. We'll set that aside for the moment. Look at the front panel. So we've got AGC in. I don't know what AGC stands for. Frequency settings, band setting, notch. I don't know whether that's, let's look at the PCB to see whether that's a jack. So these are, oh, okay. So that's high out, that's band pass out, that's low pass out, and that's notch out. Okay. And then that's in. And AGC, again, I'm not familiar enough with it to know. Trigger in, VCQ1, VCF. Then it must self-oscillate, so that's 1 volt per octave, CV in, and VCQ factor in, and then this is a pot, high-low switch, gain, again another, that's a pot, and frequency control, that's a pot. So again, except for AGC, which I'll look up here in a little bit, who knows. It's a pretty good board. There's a little bit of, they broke the boards apart and they didn't smooth off the break points. I'll get some sandpaper and do that off camera. Serge Modular by Random Source. Tells you this side faces a panel, this side faces the other PCB, which is nice. Oh gosh, they didn't even try on this one. It's got the big pieces still left on it. Come on, guys. Just a little sloppy. So it's under license from Serge Technologies, which is nice. So it's not just their interpretation, they must have actual access. So all the component values are listed. Doesn't seem like a lot of components. There's a trimmer here. It's only 200 ohm though. That's an interesting trimmer. I'm assuming that's a trimmer. And yeah, because that tracks the volts per octave, but 200 ohm is kind of small for that. A couple of ferrite beads for taking some noise out of the input power, a couple of decoupling caps and a couple of smoothing, decoupling caps and a couple of smoothing caps. ARC, I don't know what that means. Here's where the that board goes. Then we've got OPA 1234s and OPA 134, and I don't know what these chips I don't know. OPA 2134 and OPA 2134 also. I don't know what, and another one, OPA. I'll look that up in the interval when the soldering iron's heating up. The board's look good. Regular copper style plating. It's all through hole, which is nice. Interesting. We've got big pads here. I wonder if there's any surface mount there, or if they're jumpers for some reason. But we'll figure that out too. Let's take a look at the fat. I keep calling it that. Well, and my scissors are at the other end of the shop. Oh, no, the bag's not sealed, so good. I don't have to wander away. Oh, we've got 3 of them. Really? So 1, 2, and 3. Okay. Is that just a resistor bank? I'll take a look at that later, too. Now we'll go into the main stuff. Here's the mechanical stuff. Sockets. Let me take a look at one of these knobs to see what kind of quality knobs we got. They're okay. No set screw. Nothing in it but friction fit. And there's no ridges inside here, so you're relying on the ridges on the pots themselves to provide, well, to make sure that knobs don't come off. Now we got a bunch of little bags, and we got a bunch of loose stuff. So they couldn't decide whether they wanted to put everything in bags or they wanted it loose. Resistors, caps, little caps. Oh, look at that. We've got a picture. Interesting. Trimmer, another trimmer. And it tells you what it's marked as on the PCB, which is nice. A couple more caps for 41, 48 diodes, a couple more caps. Oh, those are fuses. Those are not caps. Those are resettable fuses. Another set of caps, resistors, resistor, and in here, oh, that's interesting. So they've got one TL072, that's a standard op amp, and then they've got one OPA 134, which goes, where is it? Goes here, and 3 2134s, 1, 2, 3. So one of these 2134s gets replaced by the 072. Huh. More resistors. And I'm going to make an assumption that these, which are pretty beat up, I hope they're good. I think these must be the RY and ARC, but again, I'm not certain. So I will have to look at the build guide to figure out some of this stuff. And again, there's no components on this board except for the pots and jack. Up, 147K resistor. So if you're done soldering and you say, I've got a resistor left, it goes here. And a bunch of pin headers. That's pretty much it. Looks pretty straightforward, not too many parts. So we'll get the soldering iron heated up. I'll look up this OPA 2134 and report back. Soldering iron's hot, but let's talk about a couple of things first. First thing is, for people who've watched other of my videos, I was feeling a little cramped on my close-up view from the overhead camera, so I got a new Nikon lens that takes me from all the way here, all the way out, so I'll be playing with that. Give me a little more breathing room. Let me know what you think about that. If you want a really close-up view, if you like a more medium view, whatever you want. So a couple of things, I looked through the build guide and I do recommend you do that. A couple of things to talk about first. AGC is automatic gain control. I should have figured that out, but I didn't. That's okay. Then on the build guide itself, and I have to go pull it down. Where is that silly application? I can never find it. No, don't do that. Don't do that, silly machine. So the ARC on the board here that I pointed out that I didn't know what it meant, that's automatic resonance control. And the main PCB contains an option for the original design, automatic auto resonance control, that connects the resonance to the frequency and is typically not implemented. If you don't intend to use it, leave JP1 ARC open and omit R22 ARC. I mean R12 ARC. So that would be that one labeled ARC. Even though it doesn't have an IP1, it may have it on the bill of materials or circuit listing. And the other one, and I think that's it. I think the omit R12 ARC, which I think is this, but I'm not actually certain. I'll look further on in the guide. The THAT2180s, they are not resistors, inline resistors. I thought it might have been one of those 8-pack resistor packs that are often used for banks of LEDs. No, they're actually little VCAs that are very low harmonic distortion and are tuned at the wafer level, which is interesting. Now, the other thing, and I think I pointed this out, I didn't notice whether they mentioned where the TL072 op-amp goes. These OPA 2134 and 134, those are audio optimized amps, so that's good. But that's the big stuff. We'll see what else is going along, and then there's some other things. Resistor R mod plus the TR mod trim pot determine the behavior of the automatic gain input. You can make adjustments to that if you want, because it might clip more than you want it to, so there are different resistor values you can use. Then capacitors marked CS or CY are to prevent unwanted oscillations of the op-amps. It's recommended to start with a small cap for GS next to the single 134. Ideally, that'll take care of any issues and you won't have to install anything else. Otherwise, add only if needed using COG or silver mica as small as possible in the other CS-CY slots. But other than that, it's pretty much straightforward. So we'll take a look at what we have to start with, and I think we will do we have any diodes here? I'm sure we have diodes. Yeah, we have the 4148s. We've got the 100 nano caps here, here, and there's one or two others. Instead of doing this 100 nano cap, you could put a surface mount. Alternately, you can use surface mount caps for bypass caps, but I probably would just go ahead and use the caps they supply. And here, the ferrite bead, he also mentions that you may want to replace that with the fuses in here instead of the ferrite beads. And since I generally use really stable power supplies, I don't need the additional ferrite inductor sitting there, so I'm not going to worry about that. What we're going to do first is put the diodes on the board. And they're all 41, 48, so we don't have to worry about. I'm actually surprised, since he put the ferrites and the smoothing caps coming in from power. I'm surprised he didn't put the 2 polarity protection diodes in there also. Seems like he's being rather comprehensive about what he's doing for power protection, and that's the other step most folks usually take who are caring about that, like a Frequency Central or Bafaco or Division 6, someone like that, who makes really wants their power to be really clean and protected. So I'm surprised he didn't put the big black and gray striped caps on, diodes on, that you often see as polarity protection. But let me finish up these diodes. Diodes are on, so the board takes solder very well. I guess I'll put these fuses in because I don't think he gave us beads. And again, since I use really good power, I'm not too worried about it. Let me sort all the resistors out right now. A lot more resistors than you might think. This is a relatively small board, but there's a ton of resistors. Six 330 ohm resistors. Oh, I'm sorry, I'm not going to start with that. I forgot where I was. No, he did not include the beads, so I'm going to use the resettable fuses instead. Because you got to have something. I could just jump it, but I'm not going to jump it. I'll put the resettable fuses in. Of course, you have to splay it out a little bit because the holes are designed for ferrite beads, not for a little cap. So you gotta manipulate them along to get them somewhat flat on the board. I'll solder those just because I don't want them flopping around while I'm working with the resistors. Now we'll do all these resistors, and as is typical on my channel, there's not a lot to say about resistors, so I will be speeding up the playback and probably omitting some of them. And while I do that, I will be listening to WQXR 105.9 FM out of New York City on my iPad with their iPad app, the best classical music station in the world, in my opinion. And tonight we're starting with Symphony No. 35 in B-flat major by Haydn. So enjoy resistor time. And that's resistor time for today. And again, the automatic resonance control, we're not going to do that, and we're not going to jump this jumper as the build guide recommends. Also, you're going to need, besides the markings on the board, you're going to need to look at the comments in the build guide, and in particular, you're also going to want to look at the, let me get to it. You're going to want to look at the bill of materials, because that calls out, like the 5K1 resistor is R37, but it's not marked on the board as either of those. It's marked as RY, Romeo Yankee. So you just have to go a couple of places to check things out. Now we're going to go ahead and put the sockets on. And I'm still, so we've got 1, 2, 3, 4, 5 amps, and we've got 3 of the 2134s and 1 072, and I don't see, let me look in here. See, he's got OPA 2134s for ICP, U1, U2, and U3. He's got an asterisk. Oh, okay, I see. Using Burr Brown OPA op-amps everywhere might be a bit of an overkill, but they work nicely and I haven't tried anything else. Especially for U3, a TL072 should also do. So this might be a little bit of cost saving to include the 072 for U3, which I think is that one. No, it'll probably be that one, or it could be that one. I'll take a look. I would have been fine paying, you know, $1 or $2 extra for the higher quality ones, but that's okay. Now we're going to do the caps. Let's see what we got. And there is one note on the caps. The C9, C10, and C13 marked as CS. Optional against oscillations. You might have to install a 7 pico, a 5 or a 7 pico. Otherwise install as small as possible if needed. So this is about oscillations. But we'll see what I have in the parts list once I get all done. See if they actually included it, and I think they did. Where's my 22s? Where's my 22s? There's my 22s. We'll start with the 22s, and again, I'm not going to talk through all of these capacitor installs, except when we get to the point of the C9, 10, and 13, and I'll come back and let you know what I decided to do. Sorry, in my enthusiasm, I got ahead of myself. I got to put the sockets on now, as I said. Let me dump out all the mechanical bits into that container, and we'll get the sockets out. And as I like to do, put the socket in the appropriate hole, and my hat just fell off, so if you get blinded by my thinning hair, I'm sorry. Do one leg, take a look, looks perfect, and we'll do that all the way along, making sure the notches on the board match the notches on the socket, even though, as I often say, even if the socket has a notch, always look at the underlying printing on the board, since it is really easy to put a socket in backwards, and the board is the truth, the socket is not the truth. Okay, now I'm confused again, because we've got the 1, 2, 3, 4, 8-pin sockets, and we've got, what, a 16 left, and it's not gonna, and we need another 8. That's not good. Let me look at the bill of materials just to be sure. Okay, he doesn't even list the sockets on the bill of materials, which is probably where the problem came from. And look at that, I've got 2. I actually have 2 8-pin sockets. Where on earth would they, why would they have sent 2 of those? I don't know. Well, let me go find a 8-pin socket. Had one in bench stock, Now, of course, if this happens to you and you don't have a spare, just be brave and just solder the IC directly to the board. Sockets are just in case something goes wacky. And I've got these two to put back in bench stock to replace others I've used. That's good. Kinda. Now I'll solder all these pins. And now we can get back to the rest of the caps. So, take the two styrenes. And that is all the capacitors. And I put the electrolytics on too, even though, look at that, I made that one a little cattywampus, but that's okay. And the two trimmers. And you'll notice we still have some things not on the board. Where did they go? The ARC, this CY capacitor, and I think there's one other one around here that the author says don't worry about it. Don't put those in if you don't need to, if you don't get oscillations, unwanted oscillations. The op amps recommended a small cap for CS near here, which is what we did. And then ideally that'll take care of any issues and you don't have to install anything else. And then if you do get oscillations in the op amp, you can use other capacitors in the other CS and CY slots. But we're going to assume we're not going to have that problem because there's two more CSs up here. I guess they're not just, I'm not sure exactly what he is concerned about there because we've got decoupling caps on all of these, but obviously he knows what he's talking about because he made the kit. Now we're going to do all the pin headers, and I did cut them off camera because cutting pin headers on camera is not the most exciting video one could have. And that is all the pin headers on. I'm going to separate the boards again because I've still got work to do. But I wanted to get the pin headers out of the way. That's personal preference. Do whatever you want with that. Now we're going to put the power connector on. Where is it? And it's keyed. And there's the notch on the circuit board silk screening to let you know. And just because I am paranoid about power, we're going to double check that the red stripe is on this side where it says with the keying, so we know that the pin header is on, I mean the power connector is on correctly. And now again, you know, we've got everything on here almost, and I've got these 3 extra sockets. I can't imagine why you would have put 3 extra sockets in the bag, but things like that happen. Now we're going to put that amplifiers on. And pin 1 is here. Let me zoom in a little bit so you can see that better. Pin 1 is here, and there's a little notch in the chip, and he marks it very clearly on the board where pin 1 goes, so there should be no confusion as to how that works. I'm going to do this the same way I do all multi-pin. That's thick piece of solder just keeps getting in the way. Go away. Wait until I'm doing a guitar amp. And with the installation of those parts, we're done with the electronics on the main board here. We've got, these are the caps you may want to use if you get oscillations in the op amps as he described. So don't worry if you've got a couple of spare little caps left over. I'm actually going to put the op amps on board, and I'm going to use all of the OPAs. I'm not going to use the 072. I know what a 072 sounds like, for crying out loud. But the first thing we're going to do is make sure we get the single, there it is, the OPA 134PA, OPA 134, it's important because that's the different one. The others are all the 213, 2134 PAs. So we want this one, this is the single 134 PA, and we'll want that in its socket, because if you don't do that, things will probably not work at all. May even catch on fire, which is kind of fun. And there the chips are on, and if you were counting, you said, dude, there are 5 and you only have 4 of the OPAs. Yeah, you're right. He says you can use the TL074 op amp, the Texas Instrument part, for U3, which is here, and it's not marked as U3, but if you look at it and you say, okay, if we count from the bottom, 1, 2, 3, that would be U3. If you count from the top, it'd be 1, 2, 3, so that would still be U3. So easy to see which one is U3. That's where he suggests the 074 goes. So that board is all done. That's the way it looks when it's done, with a couple of missing components, as I said, because of the not having to deal with the oscillation on the op amps. We'll see how it goes when we actually run it. Now, before I put that down, I'm going to take my handy-dandy index card, and I'm going to go through all the solder points, take a quick look at them, make sure they're all soldered, no bare wires sticking out, and making sure there's no jumpers, shorts, or anything like that around. So that's that. We'll put that aside, and we'll start putting all the controls on the front panel. Bring that parts bin back. I'm going to turn the cameras off and on to give them, reset their internal timers. Okay. Are the values marked here? The values are not marked here. One value is marked there. I think that may be because, oh no, some of them are marked. Yes, they're all marked. I'm looking at the jacks locations and saying, oh, their value isn't marked. Well, yeah, of course their value isn't marked. Yeah, silly person. When you start getting jacks with values on them, you're gonna confuse me more than somewhat. Next, I'm going to see how snugly this switch fits in. Some board manufacturers make switch lugs very tight. Some of them make them loose. I'm just going to see what this feels like. Oh, that's pretty tight. Okay, that's not... it's loose enough. I'm not going anywhere, that's for sure. Now we'll set all the jacks down. Now we'll take the front panel and put that on, and the only challenge here is the switch handle, because it doesn't have a center position. So just a tiny little bit of a challenge to get on, but not much of anything. A little clamp here. And clamp them together, making sure I don't put the clamp tip on any pins. So what I'm going to do right now is I'm going to, because I don't like to use that clamp the whole time, because I'm going to be fiddling with some stuff. So what I'm going to do first is I'm going to solder the support leg on this pot, this corner, and I'm going to solder the pins on this jack on the opposite corner, diagonally opposite. Now I'm going to take, and I'm going to remember which one I did, hopefully. I'm going to take panel nut, put it on there. Just finger tight, and then a panel nut on the socket I soldered down. And I can get rid of the clamp, because it'll stay together very well. First thing I'm going to do is this switch, because it's the one, I could put the backing nut on there, but I don't like doing that, only because, and this is only because I'm very lazy, because then I have to adjust it and all that, and I don't care. So I don't want to mess with that. So I'll just get a little piece of foam, put on my solder pad, and the handle of the switch will rest on that, so it's flat against the PCB, and I'll just solder that on. Yes, I use every last bit of solder. If you used as much solder as I do, you would too. Now we'll solder everything else down. And that is that for the assembly of the solderable components. So same thing as I did on the main board. I'm just going to double check all the solder joints, make sure I've soldered them all. I've surprised myself on when I miss them even now after decades of doing stuff like this. So what we're going to do next, he may have some, yeah, he has spacers in here. I don't know if I care. I mean, he's got little holes so you can screw the boards together, and I may as well put them in. Yeah, it would have been easier if I had done it before I put the front panel on, and I could take those two panel nuts off, but this is easy enough too. Huh. There are in fact only 2 spacers. No other spacers. Got other screws, but no other spacers. Let me see if he says anything about that. Ah, he says attach any screw spacers if desired. I agree with him. If you go on the road, if you have your rig out in a skiff or you're gigging and carrying it around, yeah, I can see using the spacers and some screws because things can wiggle loose, but in general, for me, since I just work in the studio with all this stuff, I don't care. I'm going to put this sandwich together, and then we'll go back and do our panel nuts. And I'll put all the panel nuts on real fast motion, because it's not an interesting thing to see. Now a couple of pots, turn them all the way counterclockwise, of course, first, or else you will confuse yourself later. We've got index marks, no grooves inside, no set screws, and so that means I am just guessing on getting the index marks right, which I often get wrong just by like a millimeter, but it's enough to drive you crazy when you're looking at it on the board, drive other people crazy. It doesn't drive me crazy. Next and final, we'll put the power connector, power cable in. And again, it's keyed to only go in one way in this kit, and the red stripe is over the -12 mark, which is good. So there we are. Let me come in a little bit closer. There's the front, the side, the back, the other side, the top, and the bottom. Now we'll put it in the rack and hear how it filters. Let's fire this thing up, and since it doesn't have any LEDs, the only thing we'll notice if something's wrong is it catches on fire, and it didn't catch on fire yet, at least. So let's see what we got. I'm gonna go straight from my even VCO oscillator into the filter first and see if we're hearing anything. So that's the frequency. I'm going to take the gain up. We're on band pass. So we're getting something. Turn the Q factor up. Actually, let me go over to low pass. I'm going to drop this down a little bit. I switch the switch to low. I'll take it back to high because I'm not hearing anything. I'm going to put this, I'm going to trigger this, I'm going to put it into my VCA, because sometimes it's better if things are triggered when they come in. something else. Okay. There's a spot that's hitting something. I got to find one more cable. Okay, one more cable, which will go from here to... Oh wait, I'll do it that way. Never mind. I'm going to do it a different way. Don't pay attention to the wires flying around. Oops, that's not what I wanted to do. Now we've got the LFO changing the Q factor. That sounds pretty fat, as the kids would say. As the kids would say in the 90s. I'm going to put the LFO into one other input. Now that's too short, that won't work. Take this out for a little bit. Switch. I'm going to do one other thing. I'm going to put the, or I'm going to add another thing. I'm going to take the CV from the sequencer and put it into volts per octave. Let's see what that does. I'll take that back. Oh, see, you see the difference there? Take that out for a minute and put it in here just for fun into 1 volt per oct. I'm going to go straight in with the output and take it off the sequencer. Go into notch again. Try bandpass again. I'm going to go into a different waveform out. Go back into high pass again. Slow the LFO down a little bit more. Bring up the... like the high best. Take that back out, put it back in the Q factor again. So it's a good sounding unit. It's got some interesting grit to it. Again, relatively easy to put together, but really pay attention to the notes spread throughout the build guide, because there are some things that are not obvious unless you look at the notes, and then also the bill of materials section, because that'll explain where some things go. So that's the variable Q VCF. Next, I will be building the other one from them, which is the VCFS, variable slope filter, but that'll be in a week or so. So again, good unit, fun to listen to. And I hope you enjoyed the video.